All right, how's everything going? Yeah? Cool.
Okay, except for sore back.
Sore back. I had a sore back last night, I don't know why. Just from playing violin. Questions?
How are you?
I'm okay, thanks. So no ODP for tomorrow, so spend your time studying.
Not that it causes too much
Yeah.
stress, but
Little things add up.
Yeah.
So pretty much all the emails I got yesterday about the ODP were the same problem. You got to initialize variables in C. And if you're getting weird results, if you're getting an answer that keeps changing every time you run it, almost guaranteed there's something that you're not initializing. Because most variables get kind of random values when you run them. So if your numbers keep changing, make sure you got everything initialized. Sometimes when you throw it in GDB, it works because GDB, when you compile with a -G, stuff goes in different locations in memory. And things may end up getting initialized, and so that can be kind of a red herring. But if you're running your program and you're getting strange numbers that keep changing, take a really careful look through and first time you use a variable, ask yourself, does it have a value? Am I assuming it has a value? And chances are there's something that's not being set up.
I kept trying to compile it with ODP 420 maybe, and that made it not work very
That would be weird, yeah.
Yeah.
Yeah, I try to clear those out, but I don't always remember, so.
Well, I think you did clear it out, and it just was fine with it, because then when I used debugger on it, it just really freaked out at me.
Okay. Yeah, it'll confuse GDB if you try to debug when you compile with that, because there's no debugging symbols in
Well,
the one in
there's
temp.
nothing there. so
And
it's
if there's
like-
nothing there, yeah. All right, so any last questions for the exam? Otherwise, I'm gonna keep talking about Bash.
you may have already said this, but how many questions is it? And is it multiple
A
choice?
bunch. So there's 7 short answer multiple choice
Okay.
worth 15 points. And then there's 2 Bash programs, I believe, and then 1 C program, 2 C functions.
Okay. Thank you.
Yeah.
What are the batch programs we have to write?
They take inputs and they do things and they produce outputs. So just be able to write every program like that.
Are we gonna, so I remember at the beginning of the class, you said around the midterm, we're gonna start working on GUIs, is that coming up soon?
PA5 will be GUIs,
Okay.
and it will be a group project. So programming assignment 5, you get to work in groups up to 3 people. If you want to work alone, you can work alone. But if you want to work with friends, you can have groups of 3 people. And you'll be making graphical interfaces for a system. So we'll start talking about how we make GUIs next week. No class on Monday, but Tuesday we'll go over the midterm, and then we'll start talking about GUIs, and next Friday or next Thursday you'll get your next programming assignment.
I'm sorry, but could you repeat what kind of questions are in the midterm?
Some short answer multiple choice, some Bash programs, 2 of them, 2 C functions and 1 C program, and 7 short answer multiple choice, I think. So we know how to do while loops in Bash, right? You can also do for loops, and there's a few different ways to do fors. There's sort of the traditional for loop. All right, so there's a straightforward parallel to a C for loop. So for I in curly bracket 0 dot dot 10, it means set I equal to all integers from 0 through 10. And if you do 0 dot dot minus 10, it just does the right thing and counts down from 0 to minus 10.
So in the follows the test, we don't need to increment the variable.
No, for loops automatically do that for you. That's the main difference with a while loop. So for loop says set I equal to 0, and as long as it's in this case bigger than or equal to minus 10, go ahead and do whatever's in the body of the loop. And then at the end of the loop, increment I or decrement I in this case, and go back up to the top of the loop and repeat. So it's your standard sort of behavior. You can also put on an increment, so you can say dot dot and tell it how much you want to increment your variable by. And it does that instead of incrementing by plus or minus 1. So you got standard for loops available, but not on the midterm. All right, another way that we can do loops is as follows. Suppose I set x equal to this big long string. So x is 6 words separated by spaces. Okay, we can do a for loop like this. For w in $x, do echo w equals $w, done. And it does the following. So what's it doing here? When you say for w in a bunch of stuff separated by spaces, here's the procedure. It sets w equal to the first thing it finds in that list, right? In this case, the first word, this. It executes the body of the loop. Then it goes back to the top of the loop and it sets w equal to whatever the next thing is in that list, where first thing, next thing means the stuff separated by spaces. So if you have a series of words separated by spaces, you can loop over those words by doing this for w in. Right, and this is something we'll see in Java, we'll see it in other languages. It's a fairly common construct. So
Does it have to be a W, or can you put
just any variable.
Okay.
Spaces, not commas. So for a variable in, and then you follow that with a list of things separated by spaces, and you have some body of stuff. So the action is as follows. Wow, that was loud. That's going to sound cool on the recording. So the action is set variable equal to whatever that first word is, and then do stuff. And then set your variable equal to whatever the second word is, and do your stuff. And so on up to and including the last thing on that list, and then do stuff. And then your for loop is done. right, so here's a little test script. We're going to say enter the names. We're going to read whatever the user types in, store it in names. Yes.
You have a semicolon. An echo.
Instead of a
last
quote.
echo.
Okay, thank you. That would have like confused me for 15 minutes. So we're going to read in the names, person type separated by spaces, and then we're going to use this for construct. So we're going to say for and in names, and I'm going to put this. I'm going to set number equal to 1. It's just going to be a counter. So I'm going to iterate over the names, and I'm going to echo name, and I'm going to print out the value of number is, and I'm going to print out the value of n, and I'll increment number. And then we'll just print a message when we're done. So, Nick, Phil, Barb, Jane, Morgie. All right, does that make sense? So this is also useful. So this shell variable $* can be used to pick up all of your command line arguments as a list separated by spaces. So I'm just going to echo $* and I'm going to exit. So if I just run for2, it says $* is nothing. If I say for2, this is a test, it says $* equals this is a test. So now I can use this idea of iterating so I can iterate over, I'll change my variable name just so it doesn't look precious. So for argument in $* I'm going to echo argument number is, and I'll just echo the value of $arg. So if I say for2, this is a test, I can pick up my arguments one at a time inside this for loop.
Let's just start with is.
I'm printing out argument 1 is, and then the thing after is actually the argument.
Oh.
So argument 2 is. All right, so we can also do until loops. So we can say something like x equals 0 until x equals 5. Do echo x, x equals x plus 1, done.
So is that just the opposite of a while loop?
It's kind of the opposite. It tests the condition. In this case, we want to exit the loop when this condition is true, or when this condition is false, is true, right? So we want to loop until a while statement says we want to continue to loop while some condition is true,
Yeah.
right? Until says loop until this condition is true.
Does it check at the end of the loop or at the beginning of the loop?
Well, that's a good question. So let's try this. So it appears to check at the beginning, which is different from other languages.
Yeah, the do is what I was thinking about in C.
Yeah. So do until, the until actually goes at the bottom of the loop. It's basically like a while loop. It's just it's a different sense of the condition. Yes, I believe so.
So the until loop waits until the condition is true, whereas a while loop waits until the condition is false.
Right. All right. Let's play with something weird.
Are there situations where like the until loop is more beneficial than a while loop, or?
I've never used an until loop in my life, so I'm not a good person to answer that unbiased.
Yeah, it seems like it's a lot of work to just, instead of just make a clever while loop.
Yeah, I think it requires less cleverness sometimes, though, which is, I mean, because technically all you need is a while. You don't even need for loops, but you have to initialize a variable and you have to increment it at the bottom. So we have a for loop that's more convenient. So I think it's similar with untils. Otherwise, you have to negate the sense of your condition, and that might be more confusing. All right, so let's talk a little about processes. So I have a bash shell here. Its process ID is 2111. And I can do things like sleep 1,000 seconds, right? And if I want to interrupt that, I can hit Control C, and it shows me a Control C, and it kills my sleep command, right? So let's say I'm sleeping 1,000, and from over here in a separate window, I'm going to use a command to find out what that sleep process is. So here's the sleep 1000 command. It's process ID 20290. Okay, I can say the following. Trap-L will show me a list of what are called signals. Sig hup, sig int, sig quit, sig ill. There's a sig kill down here at 9. So inside Unix, there's a way for one process to send a signal to another process. Okay, it's one of the ways that signals can communicate with each other if they haven't set something up ahead of time. Now, if you're creating a process, you can create pipelines that you can use to send information back and forth. But here we've got a process running a sleep command, and over here I've got a bash shell, right? And they have nothing to do with each other except that they both happen to be my processes. But I haven't set up any form of communication between these two processes. But nonetheless, this window over here, this process that's bash, can send a signal to this process that's running the sleep command. And it looks something like this: kill sigint, and then the ID of the process, which was 20290. And when I do that, it terminates my sleep command. And if I send an interrupt to 20111, which is my bash shell over here, my bash shell just got killed. So this is one way that processes can communicate with one another, and there's different signals available for different things. And let me see if I can find a good list. That's the same list. But by and large, most of these signals don't mean anything in particular. Now, sig int, which is signal 2, is basically like hitting a Control C. SIG HUP was for back in the days when things were connected through phone lines. That was how you could emulate hanging up a phone line. So HUP is hang up. And you could make it look like the connection had ended. And SIG quit was a different kind of quit. SIG kill is a hard kill. But here's what we can do. We can use a command trap. So let me see where I am. So my process is 20307. So I can say trap, and I can name a command that I want to execute if I get a particular signal. So I'm going to use the following command, echo, you cannot kill me, SIGINT. So what this is going to do is it's going to set something up in my process over here on the left, so that if I get a SIGINT signal, instead of doing what that normally does, which would be to terminate bash, it's instead going to execute this echo command. So now if I come over here and I say kill SIGINT 20307, nope, that didn't work.
Oh.
That was weird. My trap did not work. That's weird.
Is it because it's single quotes and not back quotes?
Should be single quotes. I know it's going to do it again, so I don't know why I'm doing this. And I don't have a network connection. Huh, well I tried this last night and it worked, but I think I tried it on the Linux server. So let me try it like this. And if this doesn't work, we'll just write it off.
Because it's SIGINT, not SIG kill.
Say again?
Is it because it's SIGINT instead of SIG kill?
SIG kill is not trappable. That was going to be sort of the punchline of all of this. So let's see if this works. So let's kill the SIGINT 20435. Nope, it's terminating, it's not trapping. Okay. Well, I'll figure that out later and let you know what I did wrong. But the idea is you should be able to set up a trap so that when you get a signal of a particular type, instead of doing what that signal does, it actually goes off and executes a command of your choice.
Man trap.
It's built into Bash, unfortunately, so you have to go through the Bash pages to find the description of it. Try it once on here. don't understand this error message I'm getting either.
Let's say IT. Why do you have a minus before SIGINT?
Because I'm hoping it fixes my problem.
Maybe
Yes,
we
it
might-
does. Okay, so that's what that error message was. So kill, you need to have a dash in front of the signal name. So I didn't have that, so I was using the default kill, which was a harder kill, not SIGINT, so it wasn't being trapped. Okay, so forget everything that just happened over the past like 5 minutes, and let's do this again. So trap, echo, hello, and we'll trap SIGINT. And we are process 20416. So over here, if I say kill dash SIGINT 20416, instead of killing it, it shows me the control C, it executes my command hello, and then it just comes back to the prompt. Whereas if I don't do that trap, and I kill dash SIGINT 20634, so it won't kill my shell, it'll just send a control C. Right? So trap lets you set up signal handling, but you can't trap sig kill. Right, that's untrappable. So it'll tell me bin bash crashed. It tells me in red. All right, so what is this good for? If you have processes that are trying to talk to one another, right? So for example, you have a process running that's responsible for printing on your machine. So it's got access to the actual printer, right? And you have 5 different jobs that want to print. Well, you print through that one process. It's called a daemon usually, or a daemon. So how do you communicate with that process to say, hey, I want to print something? Well, you can get its attention by sending it a signal. And signals don't necessarily kill programs, right? They're really just sort of a ping that says, hey, you're being signaled by this process. And it's up to the process being signaled to decide what it's going to do with that. Now, some of these things have default actions, but most of them are trappable. So it's a way to do some communication. We're probably not going to need to use that in here, but it's a good thing to know is sort of available. Along those lines, and we've talked about this before, but let me reiterate, right? If you're trying to kill a job, Control C, right, interrupts, and your process ends and it's done, right? Unless it's one of these weird things that traps Control C, like top. Nope, top doesn't. Like more. Control Z is different, right? Control Z stops your program from executing, but your program doesn't go away. It's still there. If you do a PS, that sleep command still exists. And if you sleep 1,000 times and you keep Control Z-ing, right, you've got all those jobs still sitting there.
Do they still executing?
No, they're paused. So their state, T, I don't know what T stands for, but R is running, S is sleeping, T is suspended basically. So I can resume those, and I can say jobs and see what my stop jobs are, and if I want to resume, say job 1, I can say bring job 1 into the foreground, and now I'm back to where I was when I first typed that command. And I can hit Control Z again, and it goes into its stopped state. I can bring it to the foreground. If I hit Control C, that actually terminates it. And now when I look, I've only got those 3 sleeps running now. I can also say I want that job to continue, but I want it to run in the background. So I can say background and put in the number of the job or a % sign with with that ID. And now that sleep command is running in the background, right? So after 1,000 seconds, it'll terminate on its own. So this sleep command has a state of S, which means it's sleeping, which is because it's this command PS that was actually running when I said PS. But it's different from these two sleep commands, which are in this stopped state. So they have a state of T. And if you want to kill this, you can just say kill %2. And now that sleep command is terminated. And I could kill %3. And I could kill %4, or I can kill by a process ID, which is this one. So now, that's weird. Oh, I can't kill it because it's suspended. But as soon as I bring it into the background or the foreground, it should terminate. So we're going to, probably in 2 weeks, we're going to dig into processes and Unix in a lot of detail. We're going to look at how processes get created and how we can actually make them from C programs. And it's just a bunch of function calls. But we'll play around with that, and we'll review these details because it'll be really useful to be able to manipulate jobs from the command line. But that's kind of an introduction to signaling. All right. Back to bash statements. There's a case statement in bash. So x equals hello, case, $x in. And now we can list all the possible values that we care about for x. So this is basically like a switch statement in C. So we can put in our first possibility, which is hello, and it's followed by a right paren. And then you can say what you want to do if x was equal to hello. So echo hi again, and then 2 semicolons end what you wanted to do if your input's equal to hello. And then you can put in your other option like bye, echo goodbye, show us the date, and that's the end of what we do if x is equal to goodbye. And you can do a default case, which is just a star, echo say what. And then the end of the case statement is case spelled backwards, so ESAC. So there's a big long case statement, right? But basically it's going to look at the value of x. If it's equal to hello, it'll do those first things. If it's equal to bye, it'll do those next things. Otherwise, it will say those things on the bottom. So in this case, I started off with x equal to hello, so it did that stuff. And if I bring this back, right, x is still equal to hello. If I say x equals bye, and I execute that same statement, it does the goodbye part. And if I set x equal to anything else, it'll do that other part.
What?
So nothing you can't do with a bunch of if-then statements, right, or if-then else's, but case statements are useful sometimes. So it's another programming convenience. So the syntax. Case variable in value 1, everything you want it to do, and then 2 semicolons. Value 2, everything you want it to do, semicolons, and so on. And then your default case, 2 semicolons, and then the end of your case statement.
Is default case optional?
It's optional, yeah. right? So you don't have to have anything at all in your case statement.
And
But then it
exact
doesn't do
must be
anything.
At the end of a case statement.
Say again?
And exact must be at the end of a case.
Yeah, it's like do done. It's like
Like
if
if
the.
and five.
Yeah, exactly. And as usual, you can put whatever you want in here, including other case statements, loops, conditionals, etc. All right, so here's another goodie. If space, bracket, bracket, space, string variable equals tilde, expression, bracket, bracket. And when you do equal sign tilde, this thing over here is treated as a regular expression. So for example, all right, so infinite loop, we're going to say something, you're going to read in a word, which we'll store in Word, and then this if statement says if the value of word is equal to the regular expression, caret dot 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 star. In other words, if it matches the pattern, start at the beginning of the input, match any 4 characters followed by the end of the input, right? So that will match something that has exactly 4 characters in it. And if it matches that, then it will say, okay, that word has 4 letters.
How many do you put up?
How many what?
The dot.
4 dots?
Example.
Yeah.
And any dot.
So dot matches any character, 4 dots matches any 4 characters. Caret 4 dots, $, says match the beginning of the line, followed by any 4 characters, followed by the end of the line. So anything with 4 symbols in it, 4 characters, should match this. We'll see if this works. So that's hello. Cool, cool has 4 letters. Reasonable. So we can use regular expressions inside Bash to do things more sophisticated than just is this equal to that. Right? We can say does this conform to this particular pattern. So if we want to find words that start with a Z, we can see if $word equal tilde caret Z, right? Caret says first character, beginning of the line followed by a Z. Right, so this is really powerful if you like regular expressions.
So it cannot execute ha ha ha.
Say what?
It cannot.
So haha doesn't start with a Z, so it doesn't match the regular expression. Let me show you. It doesn't match this regular expression. Right, so this will only match something that begins with a Z. Right, if we try to compare it to $, that'll look for things that end with a Z. So you got the idea, right? So depending on how you make use of regular expressions, right, this can be really useful for doing powerful pattern matching.
Is it case sensitive?
Absolutely. And it's a full-blown regular expression, so all the stuff you can do with periods and asterisks and anchors and things like that come into play. So if we just search for equal tilde AB, right, that's just asking for an expression that matches the regular expression AB. And there's no anchor, so if there's an AB anywhere inside, it will match. But it's got to be A next to B.
What if you did 2 matches?
That'll definitely match. So that's another way to play with regular expressions too. All right. Bash has a way to do menus and make them fairly easy. So here's how this works. Select X in. Let's put a list of options here. Select X in, and these are the 5 options I want the user to choose from: go, start, stop, wait, quit. Do, echo $X, done. So let's just play with this and see what it does. All right, so there's my script. Let's go ahead and run it. And so it shows me my 5 options with a number next to each one, and I can type in any number. So if I want to say stop, I can type in a 3, and it sets my variable equal to whatever that third menu item was. All right, and if you put in a number that's not in that range, then your variable gets set to nothing. So we could do something like this. So we'll ask them to make a selection, we'll print out the value of X, and then if this selection equaled quit, then we'll go ahead and say goodbye. We'll break out of the loop, and then we'll print a message just to confirm that we got outside the loop. So 1, 2, 3, 4. If they hit a 5, it says goodbye, and then we're outside the loop. So if you want the user to be able to put in more interesting responses, but you don't want to have to count on them being able to type correctly or follow uppercase, lowercase conventions, right? You can show them a list of options. They can choose one by number, but your variable's set equal to whatever that option is. So then you can use it as a string and go from there. So that can be useful. And these are all things that might help you with PA5, because PA5 is going to be done in bash, even though you're making GUIs. All right. So I'm going to set x equal to 12, and I'm going to echo $x, and it shows me that x is 12, right? And I'm going to write a one-line script called stuff that echoes the value of x. So if I echo the value of x, it's equal to 12. If I run my one-line script stuff, which should also echo the value of x, it tells me x is equal to nothing. Sadness. So why is this happening? So let's execute the PS command from inside the script stuff. Well, let me do a PS from here first. I've got my bash shell, which is 2268. I've got my PS command, which was temporary. Let's go ahead and run stuff. And when I run stuff, here's stuff. It's process ID 2804. It's its own process, right? It's not being run inside my bash shell. It's actually got its own process ID. Bash creates this new process and it starts executing. And it's a shell script, so there's actually bash, a version of bash executing this stuff inside this file. And even though x has a value here, here's what basically happens. If I run the bash command and I come into a new shell here, and I echo $x, x doesn't have a value in this version of bash, right, in this instance of bash. So these values that we set to variables are in some sense local to this particular instance of bash. And when you run a script, you're basically creating a new process. It's a new instance of bash. So there's a command, export, which changes that behavior. If you say export variable name, right, my variable still got its value here. But now if I make a new bash shell and I look at the value of x, it's retained its value. And this means if I run a shell script like stuff, it'll still have that value of x. So if you're creating a variable with a value and you want that value to be available in other processes, right, you need to export it. And so it's just export and the name of the variable. And then if you run a new shell or you make a script, it'll work. So this is why if you make changes to your bash RC and then you execute bash RC, it doesn't actually make changes in your current bash, because it's just a script and it's being executed in its own instance. All right, so I got lots of other random stuff I want to talk about. Okay, so tomorrow is your midterm. Tuesday we will go over the midterm and we'll finish up some of this bash stuff, and then we'll start talking about GUIs next week. All right, so don't miss your midterm.